All right, good afternoon, everybody. My name's Amrit. I'm with Verizon, which is a large telco in the US, for those of you who are not familiar with Verizon. We're a relatively large user of OpenStack. We have a rather large deployment. This particular talk is one which a colleague of mine, Andy Hendrickson, was supposed to be doing, but unfortunately he wasn't able to come here. So I'm going to be doing it in his place. I don't have more than 35 minutes worth of stuff, so we can have questions anytime you want along the way or all the way at the end. So by way of introduction, what I do at Verizon, I work in the team which builds and operates Verizon's cloud, one of the clouds for our core deployments. We'll talk more about what that is. In the past, I've been a OpenStack contributor, been a PTL for a project, and have been working with OpenStack for about 5 years now. So just a little bit of background, contact information, and all of that good stuff. And now we'll see if we can get this slide to work. OK, so what are we going to talk about? What is the Verizon Cloud Platform? That's our name for our cloud. Includes core components, edge components, and things like that. And the most important thing which we want to talk about was this whole notion of infinite capacity, which we think is a really, really important part, if you're ever deploying a cloud, of having something which looks like infinite capacity and why that thing is important to you. I'm going to talk about the way in which we accomplish this and how we do self-service and things like that. That's approximately the layout of the talk. So let me start by saying, so our cloud, VCP, we tend to think about it, first of all, it's a very, very large OpenStack deployment. We have more than 100,000 cores under management. We'll talk about the physical locations of this cloud, but we're in a couple of slides, but we're in several places all over the world. We have locations in the US. We actually have a location here in Sydney. Anybody here from Verizon in Sydney by any chance? I know there was, oh, there you are. And VCP does operate out of a data center here in Sydney. We view our cloud as one which is defined by its services, the services which run on it and the services which it provides, and the applications which run on it. It's largely a private cloud at this point. There are some, in other words, all the applications running on the cloud are Verizon's own. There are, however, some other enterprise customers of ours who have workloads which run on our cloud. So it's a private-ish cloud, not strictly a private cloud only. The thing which we find is really important about making any cloud successful is to make it really easy for people to deploy a workload or an application on the cloud. And we've spent a lot of time to try and make that possible. And there are some workloads which need to run on bare metal. There are some which need to run in virtual machines. There are different kinds of hardware which are in our cloud. So we've spent a reasonable amount of our development in making a variety of different kinds of hardware look almost the same, so that when you orchestrate a workload onto our cloud, you're not really concerned what the underlying physical hardware is, but you still get the benefits of those different kinds of hardware. And we'll talk a little bit about how we do that. And the last thing, any tenant on our cloud can request resources all by themselves. In order for any cloud to be successful, we believe that if you need to have a significant administrative action to provision resources, your cloud will fail. Your tenant should be able to easily provision a virtual machine, easily provision IPs, easily provision storage, put them all together, get their applications to run. That's the vision of what we think our cloud should be, and we've spent a fair amount of development making that possible. So I'm going to talk about some of our lessons learned, how we got there, and so on. For the most part, we have not contributed a lot of code to OpenStack in this entire process. We've used a OpenStack deployment, an OpenStack distribution from a vendor. and we've deployed that. So the significant portion of our development has been on how you deploy OpenStack rather than actually contributing back to OpenStack. But we are making a transition, and we're going to have more upstream contributors before long. So with that as maybe an introduction to what we do, let me go on and say our cloud, we define it in terms of these colorful things which I've underlined: a diverse and continually growing pool of compute, storage, and networking resources. You can read the rest of it, so I'm not going to do that. Let me talk about some of the important things here. First, it's diverse. There are applications which require high-performance storage. There's other applications which need just shitloads of storage. Shitloads is a technical term, by the way. Different applications require different things. We're a networking company, cell phone company. Many of our applications require the ability to do very, very high-speed data transfers in very high bandwidth pipes. So SRIOV and things like that are really important. If you want to do SRIOV, you need bare metal. Other applications run fine in VMs. So diversity there. Our cloud is continually growing. We're continually cleaning out old hardware, bringing on new hardware, migrating applications, but the overall capacity provided by our cloud is continually growing. Very important thing. One of the things which we've noticed, you never, ever have people want to give up storage. People just accumulate it. Storage is cheap. You always find a use for it later. So we rarely ever prune storage. We just come up with more storage, different performance characteristics, continuously growing pool. We have distributions all over. We have locations all over the world. It's geographically distributed, and that's because of the placement of our applications, and also for geodiversity to give us the ability within the US, for example, to have an application in multiple locations and have failover capabilities. We're a networking company. One of our biggest assets is our network. All of our data centers are interconnected. We have probably the largest network on the planet. And all of our data centers and all of our OpenStack deployments can leverage that network. And now we come to some of the important things about the cloud. We need a tenant to be able to interrogate the cloud and ask questions about where they should deploy their workload. You need to interrogate the cloud. Then you need to go provision and use it. Okay? That's our view of what our cloud should be. Not quite the standard definition of a cloud, if you will, but from our perspective, many of our workloads are in the service of, these things. So networking is really important. It's got to stay up all the time. And you got things like voicemail and people sharing messages. Storage is important. Those are the kinds of things which we think about. So again, if you have questions, stop me at any point in time, and we can dig into things in more detail. Which brings me to the whole concept of what is infinite capacity and why the hell does infinite capacity matter? We have a cloud which is in 50-something physical locations. Over time, we expect this number to be thousands of locations. And from our perspective, what exactly is the cloud? It's not just things sitting in a data center. We certainly have things sitting in data centers. Yes, we have lots of things sitting in data centers. But we also have assets sitting at the base of a cell phone tower. We have customers who've got equipment, Verizon equipment, in their IT closets. And over time, with 5G and things like that, there's going to be equipment sitting on top of lamp poles. We want the ability to be able to orchestrate workloads into all of these places where an application is not necessarily going to run in a data center, ours, yours, somebody else's, but it could be an application which runs in a diversity of places. Now, why is that important? Because of these things. There's hundreds of millions of these going around all over the US, mobile devices. We have the ability in our cloud to be within a couple of milliseconds of every mobile device anywhere in the continental US. There are some workloads where that is really, really important. Now, there are other workloads where being 150 milliseconds away from the mobile device is just fine. So unlike a cloud like an Amazon cloud, where all of your assets are sitting in a data center, say in Reston or wherever, we've got assets which are sitting in data centers, in IT closets, potentially on top of lamp poles. If you came to the OpenStack Summit in Boston, Beth Cohen, my colleague here, wave Beth, did a demonstration of a little 1U box on which we were orchestrating OpenStack workloads. We want the ability for you to have a common view of all of these assets and run workloads which are distributed across all of them. That's our view of infinite capacity. Now, how do you get there? Now, by the way, this is a slightly different definition of what a cloud is from your normal, but again, ours is a purpose-built cloud. It's built for the kinds of applications which a telco wants to use. And we get there with these 5 things. Availability, it should be available. We'll talk about each one in detail. Availability, diversity, location, connectivity, and the ability to charge back. Okay? I'll give you an example of the kind of application which I find fascinating. So Verizon has partnerships with lots of businesses. One of them is NFL. For those of you not from the US, that's the Football League. A really interesting application from my point of view is I sit in a football game in the stadium, hold up my phone. How many of you here are familiar with American football, by the way? Quick show of hands. Okay, so for the rest of you who are not familiar with American football, the rules are basically as follows, or the important thing of the game is as follows. You have multiple plays, and the idea in a play is you take a ball and move it forward 10 yards. Let's start with that. If you've ever watched a football game at home on a TV, there's this nice yellow line which they show you on TV. Well, guess what? That's not on the physical field. That's computer simulated. What if you were sitting in the football stadium, you held up your phone, the camera on your phone showed you the field, and a little piece of software drew the 10-yard line for you on your phone? Fair enough? Okay. Just the computation required to do that would mean your battery life on your phone would probably not last the length of a game. What if we had compute networking resources close to you within 5 milliseconds of your device, and we could process that image somewhere other than on your phone, and all you did was render the graphics on your phone? Augmented reality. That's a class of workload where we need diversity of processing capabilities. That capability might be somewhere within 5 milliseconds of where your device is, and all you do is inexpensive rendering on your device. So today we have mostly x86 CPUs, several 100,000 cores worth. In the future, we're looking at things like GPUs and other esoteric hardware. Different kinds of storage. Like I said, some applications require really fast storage, others require lots of storage. HDDs, SSDs, and so on, and potentially flash in the future. OpenStack already supports an easy way for you to have all of this diversity of storage and just expose it through software as volume types. So we have now common sets of volume types across all of our OpenStack deployments. So an application orchestration just needs to know, I need this particular class of service on my storage. That particular location may or may not have it, but you can choose which locations have it, and we'll talk about that in a second. But we have a diversity of storage as well. Some applications require SRIOV, also known as you need bare metal. Others are just fine in virtual machines, potentially in containers. Again, diversity. And again, we're a networking company. Each and every one of our applications connects to a number of different networks. Some of those networks are just the internet. Others are radio networks, the networks on which cell phone towers are. We have a diversity of provider networks. So each of our locations has different capabilities in it, and where you orchestrate your workload depends on where those capabilities happen to exist. Hold that thought because we're going to come back to it. The next location, I've talked about this a couple of times, but here's a map. For those of you who are within Verizon, this web page is probably something you're familiar with. If you're not within Verizon or you're not one of our customers, you're probably not going to have seen it. But the little circles on there show you where several of our US-based locations are. We have locations in, the color code indicates the kind of site which is physically located there. We have different kinds of sites. But we also have, like I mentioned, a site right here in Sydney. We have locations in India. We have locations in Europe and so on. So we have presences physically in a lot of parts of a lot of geographies. Within the US specifically, let me talk about core and edge. A core site is typically something which we consider to be in a data center. An edge site is something which is closer to your user equipment. Where exactly the edge is, it changes depending on your application. In the future, the far edge might be on a lamppost down the street from you. But the ability for you to have different locations, not just geographically dispersed, but also distance from your user equipment is really important to us. Okay. Now that you've got assets in multiple places, it's really no use if you can't connect them together. And again, we're a networking company. We've got a really good network all over the US, and we've interconnected all of our locations. And each of our locations has a diversity in provider networks. Everybody here familiar with provider networks, I hope. Okay. So with these three capabilities, you now have the ability to have redundancy in your application. You can have an application which is in, say, Branchburg and Reston. 2 locations. You have routing of traffic to each one. They're probably running active-active. But at any point in time, you can divert traffic from one site to the other and run on the other, on one site only, redundancy. And we also do things like regularly fail from one site to another just to make sure that stuff actually works the way it's supposed to. And finally, there is really no point in building a cloud and having a bunch of resources if you cannot attribute value to it. The reason why this is really important is when you associate value to something, not only can you charge the line of business for it, but it is a great incentive for the right kinds of behaviors. If you're operating a cloud and you have people who how many of you here operate clouds? Quick show of hands. Okay. How many people have come to you and said, I'd like a small VM, please? How many of them come to you and say, I'd like the largest, biggest, fattest, meanest VM possible? There you go. Well, charge them a different amount of money. Okay? An important part of having a cloud is that you're going to conserve cost. That's one of the attributes, not the only one. But if you start associating cost, and we'll show you some of the things we're doing in that area, you incentivize the right kinds of behaviors. People will start right-sizing their VMs. People will start considering having horizontal scalability in their application with multiple cheap VMs rather than one ginormous machine. Things of those kinds. Last but not least, for those of you who are familiar with the old-style dial tone, you should never, ever pick up your phone and have no dial tone. Similar for cell phone networks. It has to be available all the time. So availability is a really important thing, something which we spend a lot of time on. But again, since you need to deal with cost, you're not building this cloud on 5 nines hardware necessarily. You're potentially building it on 2.5 nines. How do you come up with 5 or 6 nines availability with hardware which is not 5 nines? Those are some of the things we've had to figure out. How do you distribute your application is one, but also operationally, how do you plan for outages and make sure that when outages happen, you're going to deal with them? So the work which we've done on this, which I'm happy to share some of the details with you, is around these kinds of things. And the reason I put the last one there, on demand, is because it ties up this whole notion of infinite capacity. When a person wants to orchestrate a workload, they should have the confidence in you that they can come to you and say, I need 300 more VMs, please, and you can provision them for them. Because if they do not have that confidence that you can give them resources, you will have hoarding. Everybody know what happens, right? Give me 300 VMs and they're going to sit there idle. Of course, this will fix that problem over time because you're charging them for it, but still. From my perspective, the time when an operator says, my cloud has succeeded, is when tenants come back to you and give back VMs and say, I don't need that no more. I know you'll be able to give it to me when I need it. This is what we talked about a week ago. These are some of the things which we've been playing with in our cloud. So let me pause here and see if there's any questions at this point. Am I running too fast, or should I slow down? Or okay. So how do we do all of this? The first and most important thing is, and again, I told you, we're using OpenStack. We're using a vendor's distribution of OpenStack. The software we've built is the thing which builds our cloud for us with that vendor distribution. Every time we make a deployment, it comes out of a set of artifacts which are strictly version controlled. We know exactly, therefore, if I look at the vintage of a particular cloud deployment, what the things were which made that cloud. For those of you who have a deployment which has manual steps, it is probably okay if you have one OpenStack deployment. It's probably okay if you have 2. We currently have over 50. 50 physical standalone OpenStack deployments running various different OpenStack releases. Various applications come onto them. We're adding new data centers all the time. How do we know that each and every one of them is going to be exactly the same? The mechanism we use to build it is strictly version controlled. The second, everything in our data centers, everything in our OpenStack deploys the physical hardware. It's asset tagged and machine readable. Every single component from a virtual perspective, every OpenStack compute, every hypervisor, machine readable. All of them are interrogatable, and I'll show you a couple of examples of this in the next slide. All of that should be stuff which you're able to look at, you're able to query, and you're able to verify. When we get a pallet of hardware, the first and most important step, of course, connect everything up and so on, we take an inventory of the hardware. And the way we do that is with software, which goes and inventories the complete rack and stores that information in a machine-readable format. That machine-readable source of truth is the thing we use for the next step of deployment, where we actually go and build the stack on top of it. Really important. The way in which we build our stack as well, it's completely declarative. We would love to say that all of our stacks are identical. They're not. We know in advance that there are different applications coming on in each place. Some locations we know need more bare metal. Some need more SRIOV. Some need less, and it's going to be all VMs. Therefore, we have a declarative way of saying you have a machine-readable state for this physical hardware. When you're building the cloud here, when you're building the stack, here's what I want you to build. It's declared in a text file. That text file is also version controlled. We can always go back, therefore, and say, how was this stack built? We want to rebuild this stack because we're deploying something new. We want a mirror image of this. Great. We can build an absolute mirror image of that stack. Okay. Once we're done with this, and we're actually deploying it, we do that. We have bots which go across the entire farm of infrastructure and periodically report consumption, periodically report health. And I'll show you some screenshots of this. And we've effectively got within our cloud a bot network which looks at each and every physical compute host, each and every volume, and tells you I/O performance, I/O capacity consumption. We can actually monitor it and use that later for a bunch of things like new workload placement, which I'll talk about at the very end. So I've talked about a bunch of things. Let me show you some actual stuff. I told you we store all of this data. For those of you who've used Ceilometer, it is great. We found it to be not the best thing for us, so we built a whole bunch of tooling of our own. And most of the stuff which we've done results in information being pushed into a MySQL database, which we can then query and do a whole bunch of things with. So here's a simple listing of every single site as of the date when we made the slide. When the actual site was built, what's the location, and so on and so forth. Completely queryable. Okay? We built interesting UIs for ourselves because we've got a number of OpenStack deployments. And for those of you who are familiar with Horizon, each Horizon web interface is going to take you to one OpenStack. On the other hand, we're looking across a number of different OpenStacks. So we built not only a mechanism for us to look, in this case, rack UI, which shows us a physical rack of our hardware and what the various components are, but we have also interfaces which will show us all of our OpenStack deployments, and I'll show you that on the next slide. We can see physically, and I didn't want to be brave and actually try to do this live, but you can hover your mouse over each one of those compute hosts, and it'll show you information about the compute host, where it's physically located, what the current utilization is, and so on. I showed you this picture earlier, the various locations we have. And let me talk a little bit about the API we built on top of this, because this is where I think things start to get really interesting. I have an application which I would like to deploy. I would like to deploy this application on some place where I have SSDs, where I have certain provider networks, where I have particular kinds of CPUs, and so on. How do I go figure that out? Well, guess what? We stored all that information, and we built this API on top of it. We call it Service Status API. It's a standard RESTful API where an orchestrator can come in and query our cloud and say, OK, you claim you've got this 200,000 cores under management and this petabytes of storage. I have this particular workload I'd like to orchestrate. Where? We've got APIs for that. And this is the one place which you can go to, Service Status API. It's currently not open source. We're planning to open source it. Anybody's interested in that, come see me. But you can query all the capabilities of our cloud in each of the many locations. And you can decide where you want to orchestrate your workload. I talked about chargeback. We have reporting for all of the things which are consuming in the cloud. You can see, in this particular case, just some sample data, how many floating IPs, how many instances, how many networks, and so on. So what value do we associate when we come up with $31 or whatever? We have a reasonable idea of what actual costs are. We're refining our model on a constant basis. And when there are things which we find are things which we want to discourage, we can tweak the cost. So when you print this report and you send it up to teams on a regular basis, you incentivize the right kinds of behaviors. Oh, by the way, you can notice on the left-hand side, this is actually our complete self-service UI. So we're just showing in this particular slide the dashboard showing costs. Again, this looks very much like Verizon, Horizon, deploy a virtual machine, and so on. But we built this completely to work against multiple OpenStack deployments. Because in our case, we don't have one OpenStack with one region 0 and all of that stuff. It's literally each and every one location is its own OpenStack deploy. Again, more to show you about how the charging works. We also have quota management, same kinds of things. You have quotas across OpenStack deploys. monthly spends, different categories, all of the standard stuff you'd expect. Consumption trends over time, something which we find to be particularly useful, because you start looking at a single tenant and you say, what's going on with this tenant? Very useful when you want to look and say, I want to do some housekeeping in a particular region. Who should I move? Particularly useful for things like that. So the stuff which we built is, it's not as sexy as many of the other OpenStack things, but it's really important for the thing which we really wanted to do, which is do this cloud which understands edge. And what exactly am I talking about? So we're looking at workloads on something like a heat map. We talked about querying our cloud and saying, I have a workload which I'd like to deploy, and I want this particular compute, and I want this particular storage. But you know what? There's one really important thing for me, which is, and I would like those resources to be within 15 milliseconds of this zip code. Okay? That is something which no other cloud currently provides. And oh, by the way, if that workload needs to move from one location to another, I would like to be able to move that location based on an understanding of network latencies. Now tie that to costs. I would like to be within 5 milliseconds of a particular zip code, but you know what? If it's going to cost me way too much to push it out onto the edge, I'll take a hit on the network utilization and I'll keep it on the core. When that application starts to be pulling too much data over a long-haul network and the cost parameters change, I'd like to divide the application and push more of it closer to the edge. The ability for us to do that is something which we want to get to eventually. So we're building in that direction, and this is our definition of infinite capacity. Billy, who's my manager, likes to call this this is basically, effectively, you're building a heat map. He calls this geological, geo-logical. Depending on where you want your workload in terms of proximity to the edge, in terms of proximity to the device you're going after, the edge device, the ability for you to orchestrate that is the thing which we're going for. That capacity is what we believe is truly infinite. So users moving down highways, 20,000 people going to a football game, hundreds of thousands of people showing up in downtown San Francisco for, say, Oracle Open World. Those are things which tax a network in a way which is very, very different from normal workloads. Or there's a hurricane. How do we orchestrate a set of network functions in a way to deal with a failed or damaged network close to a place where we need those services? Those are the capabilities we're trying to build. So that's kind of the direction we're headed. And I probably didn't mention this, but yeah, we're hiring, in case you're interested in working on this kind of cool stuff. From our perspective, we're solving problems at a fairly significant scale. We're developing software which will enable us to build the infrastructure to do that. So if that's something which you're interested in, come on over and chat. So that's about all I had in terms of slides. So questions? Yes, one, then two. Go ahead. Yeah, yes, sir.
So you were describing the platform, let's call it, as a, sort of used by multiple user groups and so forth. So what we were just talking about in terms of selecting sites for running loads and so forth based on attribute of load, is this kind of logic something that you're putting into the user-facing kind of dimensioning?
Yes. So great question. That is absolutely what we're doing. Currently, we're the only consumers of that API. If you think about how network functions are orchestrated, they typically come with some orchestration, VNF, Virtual Network Function Manager. Those managers are, at this point, not aware of this API which we've built. Therefore, they're looking for, give me the Keystone endpoint I need to talk to, right? So there is a small gap there, and we're the ones who are consuming that API to say, here's the things which that particular application owner believes their application needs. Where should we go and put them? We're the ones using that. And then we can display statistics and all that based on that. In the longer term, we'd like to connect these two. It is not something which is currently implemented or in use, but we are hoping we can bridge that gap. Yes, sir.
Yes, I want to ask you about diversity and the chargeback, because you mentioned about diversity, you want to put more option or selection for the customer. But as you put more diversity and the selection of the option, it's going to be more complex for the chargeback, right? Because
Correct.
the combination will be just be multiple.
Yep.
So just want to know how did you solve those kind of challenges?
Sure. So I'll give you a practical example of that with compute. So we had the ability, so we have some parts of our cloud where we allow oversubscription, where we don't allow oversubscription. There's places where we do CPU pinning. There's places where we do SRIOV. All of them are different flavors, shall we say. Based on what flavor of VM you decide you want to get, your cost is going to be different. Not just because of the resources you're consuming, because I can come along and say, I would like one-to-one, no oversubscription, and I would like to have one-to-one on my CPUs, and I would like to have the whole machine to myself, but I only want a VM with 8 cores. Okay? Perfectly valid use case for us. I'm stranding 48 cores. Okay? So we've built a fair amount of logic which takes not just your flavor, but your actual footprint in the cloud and use that for your chargeback. So the traditional, let's say the traditional Amazon model, where you don't have all of those options, your flavor directly correlates to what you're charged. In our case, your flavor and the other options which go with it drive your cost, in this case for cores. So we've built a fair amount of logic in that area. Some of you are probably familiar, there used to be a company called Taligent. We use their software, which we've modified a fair amount to do this. Does that answer your question? Okay. Anyone else? Yes, sir.
How do you orchestrate your workload on this edge resources that you mentioned? Let's say an application may query I want it to be within 5 milliseconds of this.
So currently, we have a couple of prototypes for that. One of them is, so right now we have prototype which shows pieces of this workflow. One part of it is all of those edge devices also have an OpenStack component on them. So at the end of the day, you're talking to OpenStack. There's a Keystone endpoint. Service Status API just tells you the location of your service endpoint. The complete implementation of all of the pieces where you can say, give me a location which has this storage, this provider network, this latency, and orchestrate a VM with this image on that location is not currently implemented. We're working towards that.
Another follow-up.
Sure.
How do you come up with the pricing model?
Very good question. I am not entirely sure of the details on how we came up with the unit costs for these things. But if, oh, Beth probably, yeah.
Because I got stuck talking about this. So what we did is we looked at our costs internally and then
So
We
if,
actually had to adjust it because the numbers came out really high.
so if you want a much more detailed answer and one which can go down to pennies, stop by later and I will try and make an intro to somebody who actually has done that. And I don't want to put him on the spot and ask him right now, but he knows who I'm talking about. If he wants to stand up and answer the question, go ahead. Okay?
You mentioned that from a hardware perspective, the hardware doesn't support the pipelines.
Mm-hmm.
And from an application layer, that's the end users, they should still keep receiving the pipelines. How did you manage to handle this?
Your application physically needs to be able to, one, have multiple copies and do failover reasonably well. There's no other way to do it. If your application can't, if your physical compute host is running at, say, 2.5 nines, a VM running on that compute host cannot possibly have an uptime more than 2.5 nines, right? If you have 2.5 nines and you have 3 copies of your application, you can surely get yourself 5 nines. But for that, you need your application to play ball.
That will have an impact on your TCO because you need more.
Absolutely, absolutely. But so I used to work for a company which made, big iron hardware which was fault tolerant, and they would give you 5 nines and all that. I will guarantee to you that having 3 copies of a VM running in 3 physical locations is dramatically cheaper than having 1 fault tolerant hardware box. Absolutely. Yes, sir.
Is there any, could you point to any innovative technology that's propelled the organization to differentiate yourselves and also increase your margin, reduce your operational costs? Is there any particular technology that you think has made a complete change in your operating?
I'll point to one, which is Taligent, which we used quite a lot. I've been at Verizon for about 6.5 or so months. Before that, I had a startup, and Verizon was one of our customers. So I've had a slightly longer relationship with Verizon. The ability to track actual consumption and actual usage is not really easy in OpenStack. Using Taligent, we were able to get, or Verizon has been able to get dramatically better at that. That's an example of, and the reason why that's important is we're deploying at fairly significant scale and fairly significant cost. And the ability for us to charge back and attribute real value to the things we're provisioning is really important. That is something which, without that, it's physically impossible for us to drive the right kinds of behaviors. That's something which I think has been a game changer for us.
What about your NFV strategy and things like SDN? Has that made a change in your organization? Have you seen any, are you able to measure change?
Yes, so there has been, so in the original design of this entire platform, a significant amount of thought was put into the kinds of applications which are going to be coming onto the platform. We can definitely talk more about it. Beth, who's here, knows a lot about that as well. And I'll put a shameless plug in for Sheeta to talk about this at Summit in Boston, so go watch that one. Anyone else? I don't know how we're doing on time, whether we're... Okay. Thank you very much. Bye-bye.